GDSC session, second tech talk of this semester. Today we're joined by Jim Medlock and Ruben. Jim has spent his career working in IT. Most recently, he's been working in information security, but for the past few years, he's been focused on infrastructure projects as a manager, project manager, and certified Scrum Master. In 2018, Jim won and completed the Grow with Google Scholarship for Udacity's front-end web developer nano degree. And in November 2016, he stumbled into the Chingu cohorts and has met many talented people in the Chingus and has been privileged to work and collaborate with them. We're also joined by Ruben. He's an information science student at the University of Bergen, and he's also the community manager at Chingu. Hello, Jim. Please take it from here.
All right, great. Thank you, Mustafa. That's
You're welcome.
I appreciate that kind introduction. So, as we go through this, feel free to ask questions in the chat at any point. I really welcome your questions because I want what we're delivering today to to really be of value to each and every one of you. So, what we're going to do is we're going to start talking about APIs very generally. We're going to define what is an API. We're going to talk about the two, arguably most popular API protocols that you can use to access an API. And then we're going to spend the majority of this time on, once you've identified a public API that you want to use, how do you analyze, the data that it contains, um, and why is it important to use some of these tools and to have them at your disposal? So let's go right on in. So what is an API? Well, it's actually really simple. An API is a way for your application that your web application that's running in a browser, or conversely, if you have a command line like a Node or a Go uh, application, it's a way for you to access data that's made available by a server someplace. And that's one of the architectural distinctions of the API. The data is not kept on the front end. It's not maintained there. The data is maintained on the server. And one of the reasons for that is, well, two reasons for that is, a lot of data comes from databases. So there's a lot of volume to the data. It takes a lot of space and a lot of resources to manage it and maintain it. Well, that's not something you could duplicate in each and every individual's PC. So it makes sense to centralize that on a common server. The second reason, which is just as important, is the fact that it is impossible to secure a web application, or actually anything running in a browser. So the web server, because of the security protocols like HTTPS and TNS and whatnot, they give you the ability to secure your connection to the server. So it gives you a little bit more not a little bit more protection. It actually gives you quite a large amount of protection, from hackers and bad actors. So that's really all an API is. Now, I use the term protocol, and we're going to talk about REST and GraphQL in a minute. But basically, to get data, your application in the front end makes a request over the internet to the API, which then responds with the answer. The answer could be, here's a block of data that you requested, or it could be, I don't have what you requested, or it could be, I don't understand your request. Well, that request and response, that's governed by a protocol which defines, how do you make your requests and what's the format of the data that comes back in the responses. Pardon me. So let's talk first about REST. REST is actually the most popular of the API protocols. It's the one that everyone who's starting out in web development uses when they first learn about APIs. Now, REST is really backed up. It's quite strongly related to HTTP verbs. So with REST, you'll issue something like an HTTP GET command, and you'll pass it a parameter, a route of all users. Well, when you send that to the server interprets that all users request along with the GET verb, and it basically will retrieve the data you've requested from a database or a file. Doesn't really have to be a database. Um, pardon me. And it'll return it to your front end application. Now, these verbs, these are defined in the HTTP standard. And get is used to read, put is used to do an update, patch can do updates and modifies as well. You've got post to do or to create a new record, and then finally a delete to delete data. So these are well defined. Now, one of the important things to remember about REST is that you know the interpretation of your requests and the format of the data is controlled 100% by the server, by the code that someone has written in the server to implement that API. So for that reason, the queries are really very rigid, and in fact, they're somewhat brittle. Uh, and likewise, the payloads, basically the format of the data that's returned for each request, those are rigid as well. They're very well defined, which means that they're not easy to modify. To modify them, you have to change server code. And if you're going to change this code on the server, you need to think about backwards compatibility. For example, if I've got, let's say I've got 100,000 users out there, 100,000 applications that are using my public API, pardon me, uh, and I want to remove a field from one of the payloads, well, that means I could potentially break many, if not all, of those user applications. So you have to be very careful about the design of a REST API and also any modifications you make to it. Now, let's compare that to GraphQL. Now, GraphQL, the queries are very flexible and the payloads are very flexible as well. And the reason is that while GraphQL runs as a server, it's the client that defines what is the data that I want. So the request and the payload is defined on the client side. Now, this has some advantages because it means that clients can request things like, blocks of data, like arrays. I could have a GraphQL query where I say something along the lines of, I want all of the employees in Department 100. Well, that would go to the server. GraphQL would interpret that. It would extract all the employee data for employees in Department 100 and would return it to my client, my web client. So that means that there's fewer requests. You could still code something like this in REST, but it's much easier to do it in GraphQL, to do that specific kind of request. So that means fewer trips, potentially fewer trips between your client and your GraphQL server. And as you all have probably learned, you see it every time you hit the enter key when you're making requesting a new web page. That network time can add up. Now, one of the big differences between GraphQL and REST is while it is very flexible, and it's more flexible actually than REST, it's also very complex. Um, it's not something that you learn in just a couple hours. Uh, REST is very easy to pick up, uh, uh, in a very short period of time, but GraphQL It has a schema associated with it. It's got query syntax. Um, Again, it's just more complicated, and that's one of its drawbacks. So, are there any questions so far? I want to make sure I'm not missing anything.
Nothing so far.
All right, great, thank you. All right, so let's dive just a little bit deeper. We won't spend much time on this because I want to spend more time on showing you curl and JQ and Postman. But I think it's important to understand and be able to compare and contrast the advantages and disadvantages of REST versus GraphQL. So again, the big one is GraphQL is client driven while REST is server driven. And that just simply means that your client through GraphQL can define what's the data, not just what is the data I want, but it can actually customize the payloads. Whereas REST, it's fixed. You make a request and you're going to get a fixed payload whose format is very rigid. Um, GraphQL also it's schema driven and it has very strong data typing. Uh, REST, you can do data typing, but all of it has to be manually implemented on the server side. When the server gets a request and you've passed something like a search key, the server has to define or has to validate, is this search parameter valid? Is it the right data type? Is it in the right range of values? All of those kinds of things. Um, they both, for all intents and purposes, they both support CRUD. That's operations dealing with creating data, retrieving, updating, or deleting. It's just GraphQL uses some different terminology. And someone the other day pointed out that the use of the term query and mutation kind of aligns with, if you're a React developer, with Remix and some of the state management tools that are available with React. Again, another big advantage of GraphQL is that a single call can return quite a bit of data. Whereas with REST, the data that's returned is hard coded on the server side. It's defined with the route. I'm going to skip some of these. The um, Really the biggest difference between the two is GraphQL has a very difficult learning curve. And I can attest to this. I've been using GraphQL for 4 or 5 years, and whenever I do use it, I spend a lot of time in the documentation. Um, Yeah, so some use cases. GraphQL is really good as an aggregator. So if your front end needs to retrieve data from multiple microservices or multiple databases, multiple different data sources, GraphQL can act as an aggregator. Your client doesn't need to know that there's multiple services. All it needs to know is what's the data defined in the GraphQL schema that's presented to it to be able to retrieve that data. Now, on the back end, GraphQL, it may be retrieving data from 4 or 5 different databases in 4 or 5 other servers. It's also good for mobile applications because of the performance aspect. Now, REST is really good for simple applications. And in fact, I really suggest that, when you're starting out just learning APIs, start with REST. Uh, it'll be faster to pick up, but it's simpler to understand, and you'll be able to get those first successes much faster than what you would if you started out with GraphQL. All right. Like I said, any questions at all, feel free to ask. I welcome them. So I want to switch now. We've gone through the basics of what is an API and what are the two most popular protocols. Let's talk about what are some of the tools needed or that you can use to, really to analyze and research an API to determine is it a good fit for your application. So we're going to talk about why are these tools necessary, and then we're going to dive into both curl and RQ uh, or JQ, and then Postman. Uh, curl and JQ are command line tools. Postman is a what you see is what you get. It's a graphical tool. And they each have advantages. There's neither one is better than the other in all circumstances. So first of all, the tools really help out when you're looking at APIs to determine, which one satisfies the requirements for your application. So let's say you're writing an app that's going to put the weather at the current user's location on the screen. There are a lot of different weather APIs. So you can read documentation, but sometimes it's hard to kind of understand, well, from documentation, what does the data really look like? So one of the things the tools let you do is they let you retrieve that data. They let you use the API without writing any code. So let's see. I'm going to pause here for some questions. For GraphQL, what is optimistic UI and can it be used with REST as well? I have to admit, I don't know what optimistic UI is. Um, if you could tell me more, I'll try to do a better job at answering that. That's just a term I'm not familiar with. And then the second question, are there any notable examples of apps that use GraphQL rather than REST? And how is the better choice for their particular service? Well, I'll give you one, and our examples we're gonna go into are based on GitHub's API. GitHub actually offers both a REST API and a GraphQL API. And I believe the REST API is at version 4. The GraphQL API is still catching up. Um, but really where I've used GraphQL and I've seen it stand out with a public API like that is GitHub has rate limitations on the amount of calls you can make to their API in a given period of time. I've found that GraphQL lets me access a bit more data before I reach that rate limit rather than REST. Because with REST, I have each call returns one bit of data, one discrete unit of data. With GraphQL, I can say things like return all of the commits or return all of the PRs or return the combination. I want to see all the commits and all the PRs together. So it's a way of I don't think it's appropriate to say I'm defeating the rate limitations, but I'm just more efficient in my requests, so I don't hit the rate limits as often, and it actually makes my code a little more efficient because there's fewer network calls. It means that I can provide the data and answers to the end users faster than I could through REST. So let's see. Thank you for this, Mustafa. Let's see. Optimistic UI is a pattern that you can use to simulate the results of a mutation and update the UI even before receiving the response. Um, Once the response is received from the server, the optimistic result is thrown away. I don't think either one have that. Where they provide you like just a little bit of the data to get started. Now, something that GraphQL has though is paging. So you can retrieve data in pages. Let's say that I ask for a result set that has, 100 rows in it, I could page those through GraphQL 10 at a time, so I can retrieve the first 10, and then while I'm formatting the UI, I'm sharing that data with my user through the UI of the first 10. GraphQL can retrieve the next 10, and then so you can retrieve the data in stages. So I hope that helps. I think that's actually the answer to that. That's a good question too. Um, so one of the other big things about why a tool is necessary, I wish I could say that documentation is always up to date. Um, but what I found is that even uh, for the best vendors, a lot of times there are discrepancies in the documentation. It just doesn't match the way the code actually runs. Uh, and I can give you a real life example of that. At Chingu, our community is based in Discord. So we have quite a few Discord bots that we've written, and we use a API, a library called Discord.js. It basically puts an object-oriented wrapper around the Discord REST API. It's very useful, and we've had a lot of success with it. But Discord.js, we've hit a few cases recently where the documentation doesn't match the way the code works. And in fact, I guess it was the end of December, I wasted about a week thinking my code, I had buggy code, when in fact, what happened is I was following the documentation, but the documentation was wrong. So this is an area you can use these kinds of tools like a Postman just to verify that the requests you make are returning the results you expect. Along those same lines, you can use these tools to test your access strategy before you write any code. We'll see in a minute that the GitHub API returns a lot of complex data. And there are often multiple ways to access the same bit of data through their API. Well, you can test out your access strategy. Um, if you're creating your own API, you have your own backend application you've written. Before you write any front end code, you can use these kinds of tools to test your API. And that's really advantageous for backend developers because quite often you will complete the backend code before the front end team completes the UI UX code. So this is a way to ensure that you're really delivering a quality results to them before they get started. Um, there's also this issue of edge cases. Um, one of the quotes, I forget who said it, but I think is very true, is that in IT and in software engineering, what we do is really managing dependencies and edge cases more than tasks. That edge cases and dependencies are far more complex. Well, there's always an edge case in any application. So this is a way where you can use these tools to search for edge cases and to identify them and identify your strategy for handling them before you write code. So in some ways, you can use these tools in design in some cases. We've talked about rate limit boundaries and we've talked about performance. So I don't think there's any need to touch on that. So let's move on. So what we're going to do now is we're going to use both curl and JQ as well as Postman to access data from GitHub through their API. Now our problem, let's just assume that we're on an open source team and we need this data to be able to track how our team is contributing to our repo because we want to do something. Maybe we want to do badging or do do performance awards of some type. We want to give the highest contributors or the most frequent contributors a coffee cup or something. You know, that's essentially our case study. And this is something we do at Chingu, actually. Uh, we monitor our members' repos, and we use it as a means to validate, to verify that are they participating in their team. Oh, so let's see. Uh, Speaking of tools, have you used CodeGen tools before that generate queries, mutations, subscriptions? Uh, I have not. I have not used AI for this. I have used, um, there are some APIs like Airtable. Airtable, when you define, your data, in essence your schema, it generates sample queries for you. So I have used that, but that's more something that's built into their documentation. All right, so let's talk about curl and JQ. These are both command line tools that came out of the Unix Linux environment. What curl does is it allows you to retrieve data from a website without writing any code. And it's available on all the major operating systems. JQ lets you interactively navigate through the JSON file that's returned from an API. And again, it's available on all the major operating systems. So you use these two tools together. You use curl to retrieve the data, and then you send that data that you retrieved, that JSON file through JQ to basically help you analyze and determine, what's being returned. So just a quick example. In fact, I'm going to skip this. Let's just go right into, wrong screen. Let's go right into some examples. Can everyone see my screen? Is it too small? If it is, just let me know. So I've created a repo, and it's got two sections, one for curl, JQ, and one for Postman. And what we want to do is let's start out. This is an example of a curl command. So curl, these dash H parameters, they define your HTTP headers that you want to send to the server. And then the URL is just that, it's the URL. And what we're going to do is we're going to pipe the output from curl into this file, commit.json. So let's just run this thing. All right, so it ran. As you can see, it's fairly fast. And what it's done is it's retrieved, it's basically retrieved, sorry, wrong file. It has retrieved all of the commits for this repo v46 tier 3 team 36. And then the output was placed in this file. So this is what's returned. This is actually the output from the REST commit endpoint or route for the GitHub API. So you can see it's an array, and each entry is for a particular commit. There's the commit ID, the SHA, and it's, it can be fairly complex. There's a lot of elements to each of these entries. There's our second commit. So again, curl just gives you a nice way to retrieve data, an easy way to retrieve data from an API without writing code. So now let's analyze this. Pardon me. And we're going to use JQ for that. Now, because GitHub has rate limits that it imposes, that's the reason I've saved this to commit.json. is I don't have to make a separate curl call for each time I want to run JQ, or for each modification I make to my JQ. So the commands I'm going to run, let's just display the entire JSON file. So what this command does, cat just basically reads that saved file and pipes it into JQ. And this parameter in JQ, it just says display all of the array elements. And so it's absolutely no different than the contents of commit.json. So let's take it a bit further. Let's say we want to display the first author element in that file. Actually, I'm going to make my window a little larger for you and for me. So you can, this is a little more concise. This command really just said, analyze the very first array element in that JSON data that was returned and return this author block. And in fact, that's what it did. And so this is how JQ can help you analyze the output from an API call. You know, you can use it to do this type of navigation before you write code so that you can understand, you know, what's the structure of the data and the relationships between the data. Again, these are things that the documentation should show, but again, as we all know, documentation is not always up to date. So there's a lot of other things we can do. So let's say that, you know, this is still too much. Let's say what I really want is I want to display just this login and the avatar for the user, the author in the first element. And so you can see this is much more concise. It just picked out these two attributes of that author element. And it uses kind of the familiar, if you know Linux or Unix, it uses this pipe command to do that. So again, you can use a lot of different options here. Like, let's say we want to display all of the elements for this particular commit author. So that's what this one did. And actually, this didn't work the way I expected it to. Did I do the right command? I'm not sure what's going on here. What this should have done, what I expected it to do. Oh, that's right. It displayed all of it did what it's supposed to. Sorry. It's this command that I want to use now. This still displayed too much data. It extracted the author, basically, element for every contributor. Well, I don't want to see every author or all this data. It's too much for me to be able to comprehend. I just want to see the login ID and their avatar URL. Now you may notice JQ, when you do these types of selections, it's not SQL, but it's using a select verb, the same as SQL does for retrieving data. So what this did is it just displayed, you know, the login ID and the avatar URL for every commit that mpark 4656 had made. So I want to pause, see if there's any questions. This is essentially JQ. To get the full uh, view of JQ, you'd need to go to the documentation, obviously, and take a look at it, play around. But as you can see, it's I shouldn't say play around, I should say experiment. But as you can see, it's very simple to use and it's very straightforward. Now let's do a different one. Let's say we want to look at let's see if I have anything very interesting in here.
Just one question.
Oh, certainly.
What's the benefit of JQ over graph?
It's you say grep.
I'm assuming it's GraphQL.
Oh, GraphQL. Okay. So JQ, it only interprets JSON data. So there's no direct relationship between JQ and either REST or GraphQL. Um, in fact, you could use JQ to navigate and display any JSON file. It doesn't have to be one that's created, from an API. So it's just a navigation tool. Now we'll see in a minute. Oh, I'm sorry. Uh, grep. Yeah, with grep, I think that the big difference is going to be to analyze it with grep or sed. It's going to take more syntax. You're going to have to. It's going to be harder to come up with the command to do the navigation and the display of the data. And it's because JQ understands the format of JSON. And so it gives you a syntax that lets you navigate through that JSON file based upon the keys and their values in the different elements, the different attributes. So let's do something a little different here. One of the other things that JQ does is it allows you to save blocks of commands. So where this would be useful is when you could use these as like a notebook in a way. As you're starting to analyze a new API, the output from an API, you could start out with simple commands, and then you could keep adding your navigation to them, and then you can replay all of these by executing this test file. So let's do this. Let's do and to do that, I'll just do a minus F command. I think it's minus F. Oops, I forgot the ending quote. Actually, that was my wrong. I didn't need a quote at all. There we go. So what this did, this actually executed all of these commands in this PRs for commit.test. Now, another area where this is useful is, let's say you've been assigned as a front-end developer to use a new API. If you're using JQ to analyze that API, you can build up your navigation commands in a file like this, put it in the repo, and now you've shared it with everyone else on your team. Now, I want to go back to the question that was asked about using JQ with GraphQL. I do want to point out that with curl, you could use curl with GraphQL, but it's not something that's very, very easy to do. And we'll see this in a minute when we go into Postman, because the GraphQL queries can be quite lengthy. And so these commands can be really, really long if you're using GraphQL. So again, I want to pause. Any questions on curl or JQ before we move on to Postman? Okay. So I'm going to put this away and pull up Postman. Let's do a quick check on the slides, actually. Just real briefly, the difference between curl, JQ, and Postman is a graphical tool. Um, and one of the things it does really well is it supports multiple protocols, like GraphQL and REST. So it's really useful if you're dealing with some of these protocols that like SOAP, that aren't always that common out in the job market. Um, I guess we better just dive into it rather than me reading slides. So the first thing that stands out about Postman is it does a really good job of letting you organize, your tests, which is really what we have here is tests. So I've created this collection called Roundtable API Research and Testing, and it contains all of my queries. So if we look at, let's go back to our get all commits for a repo. Let's look at, actually, let's look at headers. So you can see it gives you a much easier way to display your HTTP headers and their values. So let's just execute this. This is really, I'm just using a get and the URL to the GitHub API. I do a send, and the results exactly the same as we had before when we were using JQ. Really no different. So one of the options that's kind of nice, it's a newer option, and I believe it's in beta testing now, or beta testing, is this visualize option. It doesn't work on every JSON file returned from an API call, but it is smart enough that it's recognized in this case, what's returned was an array, and so it formats it as a table. So it makes it really easy to see, the individual commits in this case and who made them, and it's just a nice way of visualizing the data. Now, I say that it is nice, but there are cases where it doesn't work. And I believe this is one. If I do get PRs for a specific commit and then I visualize it, I believe, oh, this one did work. Never mind. I'll show you where it doesn't work when we go to GraphQL. Now, one other thing that's nice about Postman, um, it lets you build documentation as you go. So you can see I've added just a little bit of introductory text here. This was something I created, but I can do view completed documentation, and I can actually update this. Pardon me. Uh, I could go back to my collection, and I could select. I could either comment on an item, or I could. Oh, I'm sorry. I have to do it at this level. Or I could add documentation at a route by route level. So we could add Yeah, so I could add this here. I'm not quite sure why I'm not able to update it, but so you can see that Postman, it's a very pleasant way to view the data, but also to organize your requests. It's more intuitive than many of the command line tools like JQ. Now let's dive into GraphQL because we really haven't talked about it and shown an example yet. Let's look at this post command. This actually is going to use the GitHub GraphQL API to retrieve data about uh, repos. Let's see. How does it compare to Swagger? Is there some integration to directly push to Swagger? I don't know the answer to that, Mustafa. I'll try and find that for you. Uh, I think I think that Swagger and Postman um, are probably very similar in terms of the documentation you could create, though. I've used both, and I can't really think of an advantage of one over the other, to be real honest. I think the advantage of Postman is, you can obviously it's a little more configurable, uh, uh, but in terms of documentation, no, I think they're equivalent. All right, so every GraphQL command is going to be a post, but let's just send it. Let's see what gets returned. So you can see this is the query. So it's actually quite a bit more complex than what we see in REST, but the data that's returned is very similar. It's just a JSON file. Now, again, what sets GraphQL apart from REST is that in GraphQL, the client, I told GraphQL, this is the data that I want. And I could modify this. I could say, well, uh, let me make, well, let's see. Let's say I don't care about the ID and um, I don't care about the URL. Well, I do care. Let's say I don't care about the ID here. I'll just do the URL. So you can see for the repositories, the edges, it returned, the ID and the URL for each one. So let's see if I've done the syntax correctly. So now we can see that these ID fields for the login and the name, the ID is no longer there. I didn't change any of the code on the backend server. My front end, the backend server just presented me with the schema of here's all the available data I could retrieve. And then I selected the specific items I want to see. This is also, Mustafa, you asked about cursors and about optimistic UI. This is an example where I'm retrieving really just the first 5 teams, but I'm supporting pagination. So I'm retrieving them in pages. So this is a practical example of how that's used in GraphQL. Now, another thing about GraphQL, you can see that this funny syntax, it's $login and $after. These are parameters that I'm able to pass. They're dynamic. So I'm able to configure my requests dynamically using these types of parameters. And so in this case, I said, I really just want the repos associated with the Chingu Voyages GitHub organization. That's really what that amounts to. And if I knew a specific uh, address or reference, I could say start retrieving after this specific repo. This after doesn't make any sense actually in this particular query. Ooh, pardon me. So one other thing that's good to note about Postman. I really like the way that it handles, shorten my screen here. I really like the way it handles variables, especially around your API keys. As you all probably know already, when you register to use an API, a secured API, you'll get a unique key uh, that you can use to access it through. Well, in this case, I'm not displaying it because it's my personal GitHub token, but this bearer parameter, this is the bearer token for Jim Medlock with respect to GitHub and its API. Well, when I set this up, this actually got defined as a token uh, in in Postman, and it's not exposed to anyone except for me, which is really kind of cool. The other thing that's nice is that all of these queries, this particular collection of queries, I exported this. Uh, I basically saved it as a file, and I added it to my repo. So I'm able to, that lets me share it with other people who are working on that same repo. And this is what that file looks like. If I scroll all the way to the bottom, yeah, we'll see that this token, this is actually my bearer token, but Postman, when you export the definition, it anonymizes it. So if Ruben is going to reuse my collection, he would have to substitute in Postman his own unique API token. So this way our secrets aren't exposed to anyone but ourselves. Now, earlier, when I mentioned that curl is not really good for GraphQL, you can use it with GraphQL, but the reason why is you have to pass this parameter, which is essentially, your GraphQL query. It's all of this you'd have to pass as a parameter. And that's really, this would be very cumbersome to do in a CLI command. So one of the things that I think Postman really is good at is it's really best for GraphQL over REST because of this. The other thing is I don't recall that curl has a lot of flexibility for things like these options. Everything is, the query has to be really hard coded. So I'm doing a time check. We got about 7 minutes left. Uh, I want to pause, see if there are questions. Okay. Um, is Postman considered the industry standard for API testing, et cetera? It looks very conducive to collaboration from what you've shown. It is it's a very popular tool. There is another tool called Insomnia. And if you're using GraphQL, one of the GraphQL server packages is called Apollo. I believe they have a tool as well. So it's not, I can't say that it's the industry standard, but it probably it's at least in the top three. And one of the great things I think about software engineering is that the best vendors, like Postman and Apollo and Insomnia, if you follow their releases, when one of them comes out with a feature that the other two don't have, it's a matter of 6 months and the other two will implement that same feature. So they tend to leapfrog one another in terms of features, but they also catch up eventually with each other. So I think I'm out of, I'm going to go back to my slides. I'm out of material. Uh, I will make, I don't know if you have a copy of the latest version of this, Mustafa. If you don't, well, I'll DM you in Discord. I'll place a copy of this so you'll have it. You can feel free to distribute this to your group. And then I'll post it in inside Chingu's Discord. I'll post it in our town hall chat channel. Um, but yeah, I'm open to any questions about anything. Uh, this has just been a really just an overview of APIs and how you can use them before you write code. And I will say we do this all the time in Chingu. We're working on some modifications now to some of our metrics code that extracts data from GitHub, and we're using uh, right now. I'm using JQ to basically do that analysis before I start writing the code.
Yeah, so I think the presentation is completed now. We have a Q&A session right now. Anyone can ask any questions they want to ask. And also, I have a question. It's kind of related to this topic. But how would you
Sure.
deal with information security and not exposing your data to the public when you're building your own API? Like, what are some kind of the pitfalls that you see that are common?
You can authenticate APIs just as you can, normal logins. So really the best way is to require that on the front end, there is an authentication that the front end authenticates with the back end before you retrieve any data. Uh, and in fact, you can see that GitHub does that. I can't retrieve, at least through GraphQL, I can't retrieve any data unless I present GitHub with my bearer token, which is unique to me. Now, GitHub does allow, through its REST API, you don't have to authenticate, but you can only access public APIs or public repo information. But that's the best way is using standard authentication techniques. It's much easier in an application because if your application has a login service, uh, then your API can check to see is the session that's requesting the data, is it authenticated? It's a little more difficult through a public API if you were creating one of those.
Great. Yeah, that answers my question. I have a follow-up question to that.
Sure.
So, when you return the data, what are some kind of considerations that you put in place so you don't expose other clients' data to the same person? Like you mentioned in GraphQL, you can select some fields, but what if some of these fields are required for multiple users? How do you manage that?
Yeah, the uh, again, it's from a user perspective, uh, it's authenticating individual users and applying potentially like role-based security, so that uh, as a manager, if my role as a manager, and Ruben's role is as a clerk, presumably I would have access to more data than what Ruben would be because we've got different roles, or vice versa. You see that a lot in accounting applications where auditors have the ability to view data, but not to modify data. Whereas individual accounting clerks have the ability to view some of the data and to be able to modify some of the data. Now, there's also some more general recommendations around information security. Number one is never store anything on the front end. And it's because the browsers are just inherently insecure. Uh, so if you store something on a user's PC, uh, you don't know what other sites they're accessing, what other network connections. It's always possible for a bad actor to get access to that PC and to get access to a file that's stored on it, um, even if they're not doing it through your application. And I can give you a practical example of that. About 15 years ago, I was involved in a what's called an APT, an Advanced Persistent Threat. Uh, a company I worked at, um, we had one PC at a remote office that, for whatever reason, the security was not updated. And that PC did not have any special privileges, but it was compromised. And then the bad actor was able to jump from that PC to another one that had a little more access, and then so on and so on. They finally got inside our data center, and over a 3 month period, actually, it was over a 3 day period, we had to recut 900 servers and 3,000 laptops uh, because the infection was just everywhere. Uh, and it was not a very pleasant experience, not one I want to repeat. But that's why it's important to protect the data on the client side. The other thing that uh, I think is important is, remember, in your front end applications, you never, ever, ever want to access a database directly from a front end, or to access any kind of secure data directly from the front end. And it's because of that same reason. You know, the web app, it's too easy to compromise a web app. That's why you should always go through a server for your data access. I tell you, when I worked at another company, we had a consulting firm that actually, uh, we had paid for a particular type of service, and they gave us the software, and they said, you need to install this software so we can collect the data we need. And when we did the security analysis, we found that their front end application was accessing a SQL Server database directly. And even worse, they had the user ID and the password for that access hard coded in the front end code. So we told them, no, that you're going to have to change that.
Yeah, thank you, Jim, for sharing that. This was a very nice session. I think everyone here learned something new and it was very informative. Thank you for being with us today. It was very nice.
Oh, thank you. It's been our pleasure. Yeah, it's been a lot of fun.
Any final thoughts or closing remarks? Anything you want to promote?
No, for me, I think it's what you're doing here is very important. Sharing the information, and I think that my recommendation is, don't think that only an expert can present information like this or presentations. I'm certainly not an expert. Um, and so I think it's important when you're building your career experience, do as much sharing and networking as you can. And even if you put together a presentation that's 15 minutes long, it's something very focused, it probably has a lot of value, because if you're answering a question you have, someone else is going to have that same question. And so when you do this type of thing, you're building your presentation skills and your organization skills, and that's really something that you'll use, when you get in the job market. Nobody just codes anymore. You know. So yeah, Ruben, thank you for that reminder about Voyage 49. Uh, for those of you that are interested, Chingu can be categorized. We're a job simulator. Uh, we help our members take the knowledge they've gained in universities and boot camps and online courses and self study. Uh, when you're building your knowledge like that, you're typically working alone. So what we do is we form teams on 6 week remote team projects, and we assign a project. Uh, and basically, for 6 weeks, you follow our framework to build an application. So in the process, you refine your technical skills, but you're also building team skills and your practical knowledge of things like Agile and Scrum. Uh, you're learning how to put into practice everything that you've learned. And the goal of that, and what we've seen that it does, is when you start interviewing for jobs, that helps you stand out from all of the other applicants because you've got, more experience and more experience at working in an environment that's very similar to what's found in the real world. So our next voyage is voyage 49, which starts the first week of May. It'll be the first Monday in May, um, and everyone is welcome. If you go to Chingu.io, you can apply, and we'll take you through that sign up process. Did I forget anything, Ruben?
No, I think that's it. It's basically mostly for web developers, so front end, back end, or full stack, and designers or product owners if that's something you like as well. So
Yeah,
it's a cross-functional team. So
yeah, that's a really good point. Teams are comprised of every team will have web developers. When we have enough people signing up who are product owners, UI UX designers, and even data scientists, we include them in the teams as well.
Okay, thank you so much, Jim and Ruben. It was a very nice session.
Oh, thank you.
Chingu is doing really great work. I think the mission is very important.
Yeah, we appreciate that.
All right, this is the end of our session, everyone. Thank you so much for being here and have a good night.
All right. Thank you. Everyone have a good morning, afternoon, or evening. Bye-bye.
bye bye.
Bye.